On February 24th, the Ohio State University Extension Beef Team hosted the 2021 Ohio Cattle Feeding School via Zoom. Realizing that cattle comfort and air quality are vital to the performance of livestock, ventilation was the topic of the presentation that concluded this year's Feedlot School. Listen in as OSU Extension Beef Field Specialist Garth Ruff introduces Extension Educator Jason Hartschuh and his presentation on providing proper ventilation to manage both heat and cold stress in cattle.
Our next presentation to finish up the night is going to be on feedlot ventilation. You can see the title there. Presenter Jason Hartschuh, Agriculture and Natural Resources Educator up in Crawford County. For those of you that need some beef quality assurance credit, stay tuned till the end of Jason's presentation, and I'll put the link for that BQA registration in the chat box. So Jason.
All right, thanks Garth. And we had a nice presentation there about some risk management. So we're gonna kind of continue with that risk management side of things tonight, but shift gears. Instead of managing price risk, we're gonna look at managing livestock health risk. And talk about ventilation and managing heat and cold stress in cattle. Hopefully everybody's had lots of fun here over the last 2 days, getting all their doors open, curtains open, windows open, as we've gone from a nice cool 9 degrees there a couple of days ago and hit 50 today. So those are some big temperature swings, and you know, it doesn't seem like the warm-up's as bad as if we drop again, but sometimes that's just because when it gets cold again, we're on that downhill cycle side of diseases. The diseases actually could be occurring and infecting our cattle right now while it's warm, and then they're going to show signs here when it gets cold again. So we're going to talk about stresses and then get into utilizing ventilation and other management to control heat stress. But what is ventilation to think about here as we go today? Ventilation is the provision of fresh air to a building. That portion there, fresh air, is really important. Go into some of these facilities and you look for ventilation, and it's more like stirring the air around, just moving around warm, damp air throughout the building, and we're not really bringing in fresh air. So fresh air is going to displace heat, moisture, noxious gases, and those many airborne pathogens that lead to lung issues or respiratory distress, and also in younger animals, often diarrhea problems. So first here, we're going to look at some cold stress challenges since we're coming out of winter. It's fresh on everybody's mind. We need to think about what is cold stress in our livestock and how much did we really need to button these buildings up on those cold winter nights. So the first thing to look at is we have what's known as the thermal neutral zone of an animal, which for beef cattle runs from about 32 to 75 degrees Fahrenheit. So a dry winter coat, those animals aren't going to feel cold stress down to about 32 degrees. And as long as winter's kind to us and tempers them in a little bit, as they grow out that winter coat, potentially put on a little more fat, they can actually handle down to 18 degrees just fine without actually needing additional energy. But one challenge, and Garth and I were talking a little bit before this presentation about a speaker we might have for you next year on some mud management, but wet coats quickly take that back to a nice warm 59 degrees is that lower critical temperature. So keep our animals dry is really critical, and then we start to have to look at what's wind chill do. So those cold stress numbers would be at 0 wind speed. 0 is very rare. Typically, we're at least looking, pull up a pointer here. Typically, we're at least looking at 5 miles an hour. So when we're sitting at 30 degrees Fahrenheit, 5 mile an hour wind, that takes us down to about 25 miles an hour. Those animals are outside. Now, if we're in a barn and we can block that wind but still have ventilation in that barn, we can easily go right back up to that 32 degrees and we're not under cold stress. On those nights when we drop to 0 with that 5 mile an hour wind, that takes us down to -11. We'll see what that does to energy requirements here in a couple slides. But again, if we can block that wind, 0 is not so terrible. Inside that barn, even if it is 0, we can manage that a lot better than -11. So some different ways we can block wind inside and out of the barn definitely can help with cold stress challenges. Some of the different factors that affect ability to withstand cold, that assimilation. So cattle are going to adjust to colder weather by growing that thicker coat. They're also going to add that fat layer if we have them on a high enough energy plane. That thick fat layer, they're better able to insulate and withstand the cold much better than thin cattle. If we have respiratory issues in sick animals, though, often they lose that fat layer. May need to look at managing pens differently, moving animals after and keeping them in a sick pen after they've been sick in the winter, just because they don't have that fat layer to help withstand colder temperatures. And then metabolic rate, cattle can also increase their metabolic rate. So they increase heat production, which helps to maintain their body temperature so they don't move into hyperthermia. So what do we do to mitigate cold stress? The big things are block the wind. Wind reduces that effectiveness and increases the severity of cold stress. Monitor the weather so we know, of course, when we need to shut things up and get them open back up so we have good ventilation in the barn. Keep animals dry, provide that clean bedding. If we provide some clean bedding, if we don't have the best coats on those animals, that bedding helps to keep them warm when they lay down. And then also look at providing additional feed. So for each degree Fahrenheit reduction in temperature, below that lower critical of 13 or 18 degrees Fahrenheit, depending on how thick their coat is, we need about 1% extra energy in the diet. Going to take a quick jump though on you, because really what we're looking at managing, even more than cold stress. Cold's the easy side to manage. There's a few things here that we'll talk about later on barn ventilation that really matter, not so much on managing cold stress, but on managing pathogen loads. But heat stress is pretty critical. So that thermal comfort zone or thermal neutral zone for our cattle is about 75 degrees Fahrenheit, that upper level. And anything over 90 is considered extreme danger, and animals have difficulty coping, especially our black-hided cattle. Those black-hided cattle, if they're out in the sun, get even hotter than a lot of the other colors. So when we look here, though, an important thing is there's a temperature humidity index, and looking at what humidity does to temperature. So in this neck of the woods, nice summer day, 70% relative humidity, doesn't seem that out of the realm. And that puts us at starting for temperature stress at about 78 degrees. And the higher we get, if we're up to that 85% relative humidity, which can happen, we start seeing that heat stress even sooner. 85%, that 90 degrees where they have difficulty coping, actually drops to about 86 degrees where they're struggling. 84 degrees there with 85% relative humidity. Animals are struggling to stay cool, and we have to look at adding additional supplemental cooling so we aren't suffering from heat stress factors. A couple different resources that are out there. We don't use this a lot, but really it was developed for the western states and the open feedlots, but they do cover Ohio. USDA has a heat stress forecasting system. That system, utilizes forecasting maps that are made looking 7 days out, utilizing temperature, humidity, wind speed, and cloud cover, all as factors to make a scale risk assessment for heat stress. The more red your area is, the higher the heat stress factors. Blue is cool, yellow is in that cautionary, then red is severe heat stress, mitigation required. This is just some maps from back in July of 2020. So what are some clues to heat stress and things to keep thinking about? One question I often have for people when we start talking about ventilation and managing stress is, do you have a thermometer in the barn? These dial gauge thermometers like I have down here in the bottom of the picture may not be most ideal. A digital thermometer that has both temperature and humidity in a couple different areas of your barn can tell you a lot about what's going on a hot day or on a cold day in the winter. When highs are in the 80s with barn wind speeds below 5 miles per hour, you have pretty good chance that there's going to be stress going on in that barn. When temperature humidity index is over 80, heat stress challenges, how can we mitigate those? One important thing on heat stress is we can make it through a lot of hot days when we cool off at night, but when evening temperatures remain over 70 degrees for one night, or if we have multiple nights above 70 degrees, those animals don't have the opportunity to cool down. And then also watching respiratory rates, so we can watch their for flank movement and count breaths per minute. When breaths per minute go over 75 breaths per minute, we're in heat stress and looking at ways to mitigate that. So what are some other signs of heat stress? So normal, there's no signs that animal's laying down. They act calm, cool, possibly, hopefully chewing some cud and happy. The lowest level of heat stress is going to be that elevated breathing, potentially restlessness, and they also spend more time standing. If you typically have animals laying down in the barn and across a lot of the barn, those animals are standing up or out on the pasture or feedlot. That's a sign on a hot day that they're probably suffering from heat stress. They can dissipate heat better when they're standing, so they prefer to stand. It's more comfortable for them. Now, as we start moving into elevated levels of heat stress, so you're going to have even faster elevated breathing. You'll start to get slight drooling the more stress that animal gets. Most animals are going to be standing in the pen and restless. And at stage 2, those animals start to clump together. Counterintuitive, as they clump together, they actually continue to get hotter. But when they start experiencing heat stress, often you start to see animals start to group together. Then what do you get when you add to stage 3? Animals are going to stay together in those groups. You're going to see more drooling, increased foaming at the mouth, even higher breathing rates, and most animals, again, are going to be standing and restless. And then we move into stage 5 and 6. Stage 5 is where we start getting mouth breathers. Those animals are going to be standing with their mouth open. It's not a very efficient way for them to breathe, but it does help dissipate heat. So stage 4, you start getting mouth breathing, possibly some drooling. Some of that drooling is going to go away just because their mouth is open. And then when you move into stage 5, not only are they mouth breathing, but their tongues are also hanging out. And their breathing rate and their flank is going to look like it's pushing, like they're pushing on their lungs with their flanks. So what is the cost to heat stress? So when I start talking about mitigation strategies, we have to think about what's it worth to the operation. So the annual economic burden to the beef industry in the U.S. is about $370 million due to heat stress. In 1995, there was about 4,000 cattle deaths due to heat stress. In 1999, 5,000 deaths alone in eastern Nebraska. Heat stress also increases days on feed each year by about 7 days. Heat-related stress decreases weight gain by about 22 pounds. And another big challenge with heat stress when you're marketing during that hot time of the year is an increased number of dark cutters. That low muscle glycogen stores cause those dark cutting beef, often due to decreased feed consumption and increased stress. So what are some ways we can start looking at to mitigate stress? If we have those animals inside, we don't really have to look at providing shade. Animals that are outside, providing some sort of shade to those animals, about 20 to 40 square feet per head, and those shade structures need to be about 7 feet above the top of the animal. Animals that are inside, making sure that we have long enough overhangs on our barns. The recommendation is whatever the eave height is, 1/3 of that should be the overhang protrusion from the side of the barn to provide shade out to the edge of that barn. If we don't have those overhangs on our barns, the sun's going to come in the side of the barn. That's going to cause animals to clump away, or if they're in that area, is going to increase that heat stress on them and that stress load and total heat. So we start looking in Ohio here. What are some max air temperatures? We're thinking back, I said anything over 75 is going to be considered uncomfortable. Anything over 80 is into definite heat stress. So this is max air temperatures during the month of August last year. During the month of August 1st, we were 71 degrees. And every day after that, we had a max air temperature above 75. There was one day where max air temperature was right at 75. And then from the 6th on, we had average air temperatures that stayed over that 80 degrees for max air. Each day we were definitely experiencing heat stress during that time frame, unless some sort of additional cooling was provided to our animals. There was a few other challenges. We had 3 times during the month of August where our nighttime temperatures in a row, so 3 different blocks in a row where we had nighttime temperatures that didn't fall below 70 degrees. So those animals were not able to cool off at night. So then they were experiencing increased cumulative heat stress. So a few things to think about. We need to start reconsidering our cattle handling times. So the time of day that we reach maximum temperature, and we'll get into how long it takes an animal to cool off here in a minute, but what time of day are we reaching that maximum temperature? So across most days, there's a lot of variation here, going from 0 to 24 hours across the day, going through the month of August. But most of the time, we reached maximum daily temperature somewhere around 2 to 3 in the afternoon. So we need to remember that here as we go into some future slides. But about 2 to 3 in the afternoon is where we reach that maximum daily temperature. So if we're working and handling cattle at night after dark, they may not actually be cooled down, as we're going to see here in a minute. So from that peak environmental temperature time of 2 to 3 in the afternoon, animals actually reach peak body temperature about 2 hours after that. So 2, that's going to be 4 in the afternoon. So between 4 and 5 in the afternoon is when they typically reach peak body temperature. And then it's going to take them an additional 6 hours from when that animal's temperature peaks until it has heat dissipation throughout that animal and it's potentially back close to normal body temperature. So when we think about that, if it's 4 in the afternoon, about 10 or 11 at night is when that animal is going to dissipate heat and be back to normal body temperature, which leads us to really want to work cattle in the morning prior to 8 a.m., about 10 a.m. at the latest, and try to keep those groups to less than 30 in working chutes in tight areas so we can move them through quickly in the summer, especially in that July, August, September timeframe. Changing feeding patterns can also help manage heat stress. For many of us, we may have other jobs and different things. Morning may be the ideal time for us to feed, but typically that feeding time, so during feeding, that animal eats, that feed goes into its rumen, it's going to go through rumination, and from feeding time or feed intake, it takes about 4 to 6 hours after that until that animal has a peak in body temperature from eating. So if we think about a morning feeding at say 6 a.m., that peak temperature is going to be around noon. And then 2 to 3 hours later is going to be peak environmental temperature. So really what we're doing is we're increasing that animal's heat load. They eat a lot in the morning because that's when we fed. They have daytime high temperatures that are increasing their heat load. And then that just continues into the day until it finally dissipates. There's a few studies out there that show if we feed the majority of the ration in the evening, 2 to 4 hours after peak environmental temperature. So if we're peaking at about 4 in the afternoon, that's going to be 6 to 8 o'clock at night. We'll see a little bit better intakes and rates of gain, and those animals won't get as hot throughout the day by moving feeding time in the summer into the late afternoon, early evening. Those animals are dissipating that heat as the day cools off, as they're also accumulating heat from rumination. Another important factor for mitigating heat stress is going to be looking at how much water we provide. So anytime temperature is above 80 degrees during the day, an animal should be drinking a minimum of 30 gallons per head. And really, we should be providing for them 3 linear inches of water space per head in that pen. And that's one challenge with our frost-proof fountains that we use here across a lot of the northern part of the state. These mirror fountains that you're looking at here with this ball in them, if you can't open these sides up during the summer, you're really down to, on each side, those are about 12 inches across. If you're looking at 3 linear inches per head of open face there for drinking, that one hole technically should only be serving about 4 head, one fountain, 8 head. When we go to these larger tip style tanks or open top tanks, we have a lot more linear inches of water space on that tank to allow animals to come up and drink that cool water, which helps dissipate their heat load. Some other things we can do is look at ways to improve pen airflow, and this is really going to move into that ventilation side. Looking at what we have around our building. So a 40-foot tall windbreak, it's awesome in the winter because it stops that wind chill factor. But a 40-foot tall windbreak is actually going to obstruct airflow for the next 40 feet downwind. So we're going to have summer challenges with those windbreaks quite often, and even some woods. We'll place these buildings close to woods. We think we're far enough away, but those tall trees, 40 foot plus in the summer, are actually going to obstruct that airflow for at least 40 feet. And then we want to provide between each building. If we have multiple barns on the farm or we're looking at building a new barn, ideally we're going to have at least a minimum of 150 feet between feedlots in the barn or between multiple barns, so that wind obstructions aren't there and wind has time to go up and over through barns and pick back up to go through your next barn. Looking at ways to improve pen airflow naturally or mechanically, utilizing ventilation, or we'll look at a little bit here using sprinklers during heat dissipation periods. So around that peak heat stress time, right after that, using possibly sprinklers to help dissipate heat, or early in the morning to make sure animals are cool going into that heat of the day. So when we look at ventilation, cattle are giving off heat and moisture. They produce manure and urine, which increases the moisture in the buildings. Also gives off ammonia gases. Those ammonia gases, a lot of times, if I'm working with youth, I tell them to walk in the barn. If they can smell anything besides the smell of besides what their animal smells like, if they sniff that animal's coat, that's probably ammonia gas. And those are things they need to look at dissipating in those barns. Ammonia gas is very hard on lungs. A lot of producers, go away from, say, anhydrous ammonia because that ammonia is so hard on lungs that they have issues with a tank, needing really good sealed up cabs for corn production if you're using anhydrous. Those ammonia gases can have the same effect on livestock. If you don't know what ammonia smells like, or if your kids are ever asking, just go buy a bottle of ammonia that you can use for cleaning around the house and farm. Take a good whiff of it. If you walk into your livestock facility and it smells like that, it's too tight, needs opened up, and we're actually causing respiratory stress. Smell for stale air. Stale air needs removed. It's going to have excess gases in it. Any way that can we replace that with fresh air is going to help avoid respiratory problems. So here's some examples here of a barn I work with and some ventilation issues that are going on. This barn can ventilate very well. The issues, as I show through here, are mostly man-made issues because we're not managing the curtains properly. So this is a cool day in the winter. So this barn is 100% open on the east side. So you would think it should have good ventilation, but it's a dead end barn. We don't have a lot of wind that comes out of the east, so maybe there's a little bit of suction of some stale gases going out. But over here on this side, the west curtain is fully closed, and there's no ridge open up here. There's actually very little ridge up here that can be opened. And there's very little ridge venting on this barn. So when those animals start getting up on a cool morning, you can really see that that barn's shut up too tight as that steam starts to rise. If you were down there close and put your nose right at their level, there's a definite ammonia smell. And this can be mitigated, as we'll see here in a minute. Some more of this east side open only, dead end ventilation in this barn. So it's monoslope barn attached to an old hip roof barn. So it's kind of that shed design, not a true monoslope, because those would actually be open on both ends of the slope. Under the old barn, you can see a lot of steam rising. Those heifers don't exactly look the most comfortable, and there's a definite smell of ammonia in there. On that cold winter morning, it's shut up so tight with that west side shut. Instead of letting some air in, we actually have frost due to the high humidity in the air forming up on the rafters because there's nowhere for it to go. You can see really heavy frost down here on the steel truss and even some hanging from some cobwebs. And then you look at this bale of straw. That air was so moist in there that it settled in on the straw and created those nice little winter icicles, a little crystallization on the straw. It might look pretty, but that's really poor air for our livestock. And that's why the one side of the barn has all decided to move outside. They would much prefer that outside air. They can stay warm just fine. They're blocked from the wind, and there's good air quality outside and sunshine. They don't care that it's cold. That morning, it was a nice warm 9 degrees, and they're standing outside much more happy than in the barn where we needed some ventilation. Open those curtains up. This is the next morning. Of course, there's a little bit different weather factors, but almost the same temperature. 11 degrees that morning. Open that curtain up about a foot. It's not perfect because it opens from the bottom, not the top. So about 4 foot up's where the air comes in. There's about a 4 or 5 mile an hour breeze that morning. There's none of that steam or fog in the barn. The heifers are much better air quality. You don't smell that ammonia when you walk in. You can put your nose down with their nose, and it's going to smell just fine. That's an important part of it. When you're standing up, you're not where they are. You're where they are when they're eating, but you really need to put your nose down to the same level they're at when they're laying down. If you smell that ammonia smell at that level where their nose is, that's a sign that you have those respiratory challenges. So when we think about ventilation systems, those pictures really show that importance of the inlet for the system to allow fresh air in. And then you need that exhaust to remove some stale air. And ideally, we're going to have that control system. Of course, if you go back to that barn, if not managing that control properly, we can take something that can be well ventilated and turn it into poor ventilation conditions relatively quickly. If we're looking at designing a ventilation system, trying to figure out how much air we need to get in, here are some different factors to think about and how much we need. So a lot of times in air systems, we talk about cubic feet per minute, whether it's a natural ventilation system where we're dealing with just wind flow, or if it's a mechanical system. So for in the winter, we need about 10 cubic feet per minute for calves. If we're bringing in wean calves and feeder cattle, 12 to 15 cubic feet per minute. And then those 1,000-pound cattle, a minimum of 20 cubic feet per minute. When we move into warmer weather, not summer weather, but warm weather, that 50, 60 degree weather, calves need about 120 cubic feet per minute, and feeders 300, fats about 400. I've had a few questions lately on ventilation for calving barns. And when we start calving in January and February, there's a lot of benefits to calving inside. A little bit warmer for those calves, but we also need good ventilation. When those calves are born, they're predisposed to a lot of different diseases, and poor ventilation in calving barns are going to give you a lot of challenges later on in your operation. So if you bring about 10 cow-calf pairs or 10 cows into that barn to calve, when that calf hits the ground, you're looking at needing about 510 cubic feet per minute. Really important in calving barns, though, is to mitigate draft. We don't want that wind blowing directly on those animals. We want it blowing over the top and kind of sucking out. And there's some different options to achieve that. When we look at natural ventilation, one challenge we often run into, especially in winter ventilation, is we either don't have ridge vents or those ridge vents aren't open enough. If you go back to that heifer barn I was showing you, if that barn had ridge vents, we probably wouldn't have seen that frost accumulation on the rafters like that if the ridge on the old hip roof barn would have ventilators on it. Because what we really need is we need that ridge to be open and start to get that chimney draft effect with no wind outside. There's going to be some air that comes in, follows that roof line up. It's going to gently pull some of that warm air up and out to exhaust moisture out the top. When we get the wind blowing over it, we get that Venturi effect like a chimney works. We have air coming in the ridge or out the ridge in the rafter truss openings or a slight drop down curtain. We get some turnover of air that's slow down here so the barn stays warm. It doesn't freeze and the animals don't experience draft. And then that air exhausts out some of that damp air. When we move into summer, those ridge vents are just as important as that exhaust and additional ventilation. As wind blows across, sun warms up the roof, that hot air in the top needs somewhere to go, and it goes up and out that ridge vent. So things to think about on ridge vents, we need open eaves. We go back to that slide, we need air in and air out. If we have a ridge and we shut up the sidewalls tight, it's not going to work properly because we need air to come in somewhere. And the last place we want it to come in is down around door openings and things at the bottom of the barn. Those areas create draft down by our livestock. We want that air coming in high by the top of the roof and to get this gentle movement upwards or that slow turnover of air. We also need adequate roof slope. So 4-to-1 or a 312 pitch to take that air up and out. Anything less than that, you don't really get a good chimney effect. The air doesn't move up along the roof. It just kind of gets captured. And some other challenges are, and we'll see here in a minute, some different things that act as baffles, especially when we start putting roofs together. Or if we have on our rafter beams, if we have boards running in between those to support them, those small boards can actually act as baffles and catch some of the air so we don't get that nice drawl up along the roof line. We want to be free from wind shadows where that building is, and ideally we're going to have an east-west barn orientation. Sometimes you can't change that if your buildings are already there. You may not be able to change east-west orientation, but we can still improve ventilation by making sure we have large enough ridges and open side eaves. Going back to those old hip roof barns, a lot of people like to take those ridge vents when they tear the barn down and they end up in people's houses and all over town. But those were really important. Those were part of the chimney effect on barns. You don't see a lot of them. I've been in a couple older dairy barns where they actually built chimneys the entire way down through the upper mow in those two-story barns, and the chimney opened up into that bottom area. A lot of our older barns don't ventilate well. Those bottom areas get really stuffy. Those chimneys really help draw that air out by taking those all the way down to the bottom. Instead of having the air have to come up through hay holes or holes in the floor and waft up through that big open area in the barn, those low chimneys that went the whole way to that mow floor improved ventilation. So when we look at ridge vents, like the one over here on your right, we really should have this opening here in the ridge be a minimum of 2 inches per 10 foot of barn width. So if we have a 40-foot barn, that's going to be an 8-inch width here in the ridge opening. And then we can cover it to prevent snow and rain entry on a bedded pack barn, especially. Some different things we can do. We can put that ridge vent on and then have a top on it. That top should be the width. So if it's an 8-inch ridge opening plus 12 inches. So we're going to have a 20-inch top on it. But then if you think about wind blowing up across here, the wind's going to blow snow up this roof and drop it into the barn. If that's something you're struggling with, you can actually put baffle blocks here on the sides. This will still work good because you're going to have an opening under the cap. So between that baffle block, which is going to be somewhere between 1.5 and twice the width. So this is an 8-inch ridge. Or an 8-inch ridge opening, about 12 to 16 inches will be these baffle blocks. And then above that, you need that 8 inches unimpeded minimum. So if it's an 8-inch ridge, our space between our baffle block and that top cap on it, or the top hat, needs to be that same ridge vent opening of a minimum of 8 inches to get the wind to blow through there and get it to draw properly. If you're going to go with a chimney system, chimneys, like say they go all the way down to the barn floor, you need a minimum of a 0.5 square foot per 100 foot of floor space. If those chimneys don't go all the way down to the barn floor, if they are exhausting through that hay mow area, these older barns, you need 1 square foot of chimney opening per 100 foot of barn space in a 2-story barn. A few other things to think about if you're going to go with chimneys on these older barns. They can't be any bigger, or they're not very effective if they're bigger than a 4x4 square. And also you may want to look at some baffles. Baffles in those really help get them to draw properly as that chimney effect works in the winter as wind blows over, and also in the summer. Some other things to think about when you're putting ridge vents on the barn, it's recommended that you stop back about 8 to 12 feet from the ends of the barn. By stopping in that 8 to 12 feet range from the end of the barn, you help to prevent downdraft. If these ridge vents go all the way against that far end wall of the barn, sometimes you'll get downdraft and swirling against those end walls, which will give you a cold spot in the barn. Looking at that slope for ridge vents to work properly, we're really looking at that 312 minimum up to a 612 maximum pitch. When you get up to that 612 pitch, those steeper roofs actually reduce effectiveness. So the air comes in the eaves and goes so quickly up and out the ridge vent that they actually cause issues where it moves too fast and it doesn't draw the air out of the bottom of the barn like you want it to, or get it to mix, and you can get a little bit colder barns. The other challenge is rafters need to be open. Cross boards are going to create problems, or when we add these additions and we butt them into the side of the barn. This barn here, that's not quite 312, so this pitch is a little bit too low, but this one does come in nicely. You can't see inside this barn, but it's fully open. All the siding was removed so that hot air can come up into this old barn and go out some ridge vents on that barn. This barn over here, and I'll bring in another picture. You can see this roof. It's not quite 312, but really close, but it's coming into the bottom of that hip roof barn. And when we look inside that barn, it's coming into a dead end. When this outer curtain, so where you're looking in this barn, it's a garage door, but right beside that's a curtain that drops down. In the winter, air comes in there nicely and moves up through, but then this barn was never opened up when this picture was taken. And this siding right here basically acts as an air damper, so you don't get good winter ventilation on that section of the barn because the air starts to come in and basically it's a block, so it quits coming in due to that dampering effect as it's rising along the rafters. Looking at some ideal barn siding openings, a lot of this you can't change, but if you're building a new barn, some things to think about, the ideal sidewall height. So in the winter, we want a sidewall opening on a 40-foot wide barn to have an 8-inch opening. That may be achieved just by a rafter opening sitting there on top of your trusses, or you may need to use some form of drop-down curtains. You can see down here on this barn, it's got that overhang on it to prevent sun from coming in. Does a good job of shading the animals, and it's also got this drop-down curtain that can be open for winter ventilation. I really wish I had a good picture of this one because some things have changed so it doesn't draw like it used to. But it used to draw right through this curtain, and you'd come in on a winter day when you had just the right weather, and you'd actually see that steam look coming out of these 3 ventilators across this barn. When you go to taller, wider barns, 50 feet, you want at least a 14-foot summer opening. So this sidewall from the top of these boards or poured concrete wall, you would want a minimum of 14 feet from the top of that up to the header board. When you go to wider barns, 70, 80 feet, 16 feet opening in the summer, 100-foot wide barn should be up around 18 feet openings. A 70-foot barn, you want about 14 inches of winter opening here at that eave. Looking at monoslope barns, there's a lot of popularity and interest in monoslope barns as guys are looking at building new barns, and there's some older monoslope barns. I was just out to one here a month or 2 ago, probably an 80s build, that with a little bit of help, it could make a really good barn. So on these monoslope barns, the ideal opening is to face this high side to the south. You really want to stay with that 312 or 412 pitch for good air movement up the rafters in the winter. The rear wall, which should be that north wall, needs a minimum of 10 feet of opening from the top of your concrete to the trusses. And then again, that'll kind of depend how wide your barn is. So on a monoslope barn like this, if we have 11-mile-an-hour wind outside, and in the winter we have a 1 to 2 foot opening on the front and back, we're going to get about 10 to 70 changes. So about 10 changes with a 1 foot opening and 70 changes with a 2 foot opening on that back wall. And then a 10-foot opening in the summer is going to get you about 160 air changes per hour. These barns are nice when you have a south wind. They actually pick up wind speed as they move through the barn and really improve ventilation. You would really need a north curtain on these barns in the winter to help maintain animal comfort. You wouldn't have to have this south curtain on most feedlot barns, or at least not this entire south curtain. You can see on this barn, there's 2 curtains that roll up on the bottom and then 2 that drop down. So in the summer, these bottom 2 are rolled up. In the winter, they're closed all the time, and most of the time, the top 2 curtains are dropped. This very top curtain is rarely shut on this barn, allows good ventilation throughout the winter and stays surprisingly comfortable in there. There's some questions about roof insulation. How does that fit into ventilation? The ideal temperature difference inside a barn is no greater than 5 degrees from what the outside temperature is. So insulation does provide some benefits though. So looking at an R5 to R10 roof insulation, you minimize condensation under that roof, so it helps protect roof quality, helps protect dripping and roof integrity. And also in the summer, it reduces the amount of radiant heat flow into the barns. So when that summer sun is shining, it warms up the barn roof and actually radiates down into the barn. A little bit of insulation in there. Instead of all this coming through, we get some of it that gets caught or bounces back off. Improves that summer temperature some. Going back to those calving barns, another option for calving barns besides some sort of ridge vents and things is positive pressure ventilation. Anybody that's starting bucket calves potentially on the call, tonight. This is something you may want to look at for winter. So these positive pressure ventilation systems, they have a fan unit in that outside wall that's actually pushing air in. We shoot for a ventilation rate of about 15 cubic feet per minute per calf. The nice thing about these systems is they minimize draft. Because this is coming in this tube and the tube has holes punched in it, and we angle them down into those animals' pens, the air velocity by the time they reach a calf is less than 50 feet per minute. So they really can't feel that, but it's enough air velocity that it moves that stale air up and out of the pens. You still need some ridge vents and eave vents so that it has a place to leave the barn. These tube systems, they work well up to about 30 feet per tube and about 100 feet of length out of each tube. If that's something you want to look at, we can work with you on designing those systems. They're not quite as easy as just looking at your barn, measuring how long it is, and ordering up the tube. You have to figure out exactly how long it is, what the width of the barn is, how many cubic feet per minute you need to have, and then what size of holes to punch in that tube. And the size of holes you punch actually can change as you go across the further down the tube and what angle to put them at so you're hitting in the calf pen. You don't see a lot of beef facilities that add fans, but there are a few out there, especially when you get into a few of the high-end cow-calf operations or some indoor housing, a few feedlots that do use some fans. So cattle prefer fast air when it's hot. It's more of a physiological thing. It has very little positive effect over 5 miles an hour on cooling, but they'll all line up and lay in a line or stand in a line at those fans when it's really hot out. So when you're adding fans to your system, think about where you want them. If you want them to encourage eating or lying, which one's going to be your priority? If you don't want to put them in both locations, some things fans really help with. On that lying area, if you have some dead zones in the barn, a lot of times counterintuitive, but animals like to go bunch in those dead zones. By putting fans there, we can decrease bunching. We spread those animals back out. We help them cool. Those that even aren't in that fan area because they're not bunching stay cooler. When we look at wind speeds, so the minimum cooling airspeed we want in a barn is about 2.25 miles per hour or 200 feet per minute. And this is pretty easy to test. For anybody that has a good wind speed measuring tool that they use for their sprayer, you can take that same tool and start walking around the barn. Walk into those dead zones in the barn where animals are starting to bunch. See what the wind speed is in those buildings. If your sidewalls are all open and you think they're well ventilated, but you still have bunching, see what the wind speed is there compared to other areas. Also look for that shadowing and sun effect because the animals do like to avoid areas that are in the sun. And when you start trying to install fans, you're going to find very little benefit of wind speeds over about 4.5 miles an hour on actual cooling. It may feel good, but you don't increase cooling when that wind's over 4.5 miles an hour. So that's something you can look at. If you already have that wind speed in a portion of the barn, you may have other challenges that adding fans aren't going to help you with. When you look at adding those fans, determining what angle to place them at, using that wind speed anemometer to determine how the wind is blowing through the barn is pretty important and where you want them. You need to be, if you're going to put them in over a lying area, you want to be at that 2 to 3 foot area, which is the top of the animal when they're lying down. If you're over a feed line, you may be more up at that 5 foot area for where they're standing up. So these are 30-foot fans. We used to say a 30-foot fan would throw or a 3-foot fan would throw about 30 feet. That's not so much the truth anymore. A 3-foot fan throws, we're saying about 24 feet today. You don't get as much throw as we used to say. Really probably never did get the throw, just are doing a better job of measuring them. So every 24 foot, putting a 3-foot fan, that fan is going to take it about 20 feet before it reaches the ground. So we need that fan, and then you'll get, another 20 feet out of it, 24 feet until the next fan reaches the ground. So placing multiple fans across the barn and making sure we set them back far enough from our dead zone. If we have a dead zone here in the barn and we put the fan right above it and point it down, unless we point it straight down, it does little good. We need to set it back here about 20 feet so that it's hitting that dead zone when it comes down. And just taking your wind speed monitors and testing those, seeing where they're actually hitting. and adjusting them. And by 50 feet, basically that wind speed coming from the fan is totally gone and lost. High volume, low speed fans. There's some great places where they fit. They do a nice job of mixing air and minimizing those dead zones. So if we have some ventilation in the barn, but we still have dead zones, fully open barn, we get pretty good airflow through it, but we have some dead spots in it. We can use these high volume, low speed fans mounted up in the rafters. They're very quiet. They recirculate the air through the barn. But if we go back to ventilation, there is a key point there is that it brings in fresh air. These high volume fans don't bring in a lot of fresh air, but they do mix the air in the barn, minimizing dead spots, maybe providing some fresh air to them. These fans, depending on how big it is, can cover up to 40 feet. They're great for bedded pack in areas that are very open with no posts in the barn. What do we do with, I've heard multiple people calling this, and I like the term, the dungeon barns. So those old block barns, every now and then we'll put cattle back in those. This one here has some nice windows in the side of it, which could be beneficial, but we're still not going to get it open like we want. You know, go back to that slide. If that barn's 40 feet wide, we would want a minimum of 10 to 12 feet of sidewall opening here, and we're not going to get that. So how can we ventilate these barns better? It really comes down to positive pressure mechanical ventilation or negative pressure ventilation. Can we open these ends up, turn them into more of that hog barn style ventilation, and use these windows as air inlets and suck the air out? Or go back to those positive pressure tubes, but go with much larger tube systems and push air into the barn. It's going to be more expensive. It's never going to be as good and effective as a new tall barn, but it can work very well and decrease respiratory distress in those animals. You may still get heat stress, but under a lot of situations, we can get enough fresh air in there that on most days we don't have gas buildup of those noxious poisonous gases that cause lung problems. As a last resort on really hot days, this is a Western feedlot. Those sprinklers aren't just for dust mitigation. They can actually be used to help cool cattle. In most of our systems, they don't work well unless we have some form of scrape alley that we can put them in. If we're in a bedded pack barn, you really don't want to have sprinklers. If you're in some sort of scrape barn, sprinklers may work. When you're going to utilize those, you utilize them early in the morning and after the heat of the day. You really don't need to use them at the hottest point of the day. While you feel like that would make a lot of sense, they really work best to help cattle cool down and encourage eating. So putting them along the feed line is helpful instead of the entire barn. But during the heat of the day, the problem we run into is they actually increase humidity. Those sprinkler systems, during that hottest portion of the day, you have higher humidity in the barn, which increases lung challenges. You really want to use them in areas with rapid airflow, and you need large droplets. So a fine mist, those mister systems on our livestock don't really work. The water never reaches their skin. We need large droplets that can penetrate down through that hair coat, reach the skin, and then we need a wind current blowing over the top of that to evaporate and create evaporative cooling with our animals. So really a sprinkler system combined with a fan system is going to be ideal. So fans are probably the first step. And then if you need more heat mitigation or still seeing high levels of heat stress, some sort of sprinkler system along a feed line could be helpful. So when we look across all these different ventilation systems definitely save money and improve growth. If we get those natural ventilation systems designed correctly, they cost us nothing. Curtains are cheaper than siding a barn. So they're not going to last as long, unfortunately, those steel siding, but doing a good job of taking care of them, using some sort of heavy panel so livestock can't lick and rip at them, like a little bit tighter weave than a cattle panel. So the problem with cattle panel along curtains is that those animals can actually stick their noses through them and lick at them. And if you happen to be lucky enough to raise in Holsteins, once they get a small Holstein, they just keep chewing on it and make it bigger. I'm sure the colored cattle guys are saying their critters would never do that. Unfortunately, I've seen a few colored cattle chewing on them too. So a little bit tighter weave so they can't get their nose through, but you also don't want to go as tight as bird barrier. We used to use bird barrier on curtains. It was very common, but those bird barriers actually decrease wind speed. A checkered pattern slows down that wind coming into the barn, that ventilation potential. So you want as wide of a guard as possible, but just small enough a nose doesn't fit through to chew on them. We're also going to decrease those respiratory issues because we're getting those gases out of the barn. On young animals, we decrease scours because we're moving out those pathogens. Then you go back to that rate of gain. Typically on heat stress, you're going to see heat stress cattle at least 1 extra week on feed and lost gain. I see we got a couple questions here, so I will jump over to those.
Jason, the one in the Q&A box, what companies sell or make barn curtains? Where can we find those here in Ohio?
Yeah. So it depends what weight you want to use to get barn curtains. The farmer boy who builds a lot of the hog barns is one place you can get barn curtains. They sell a lot of drop down curtains, and they can work really well for drop down curtains. One small challenge we've had with the farmer boy curtains is they are a little bit lighter. So if anything starts chewing on them, they don't last anywhere near as long. Or if we get some wind damage. And they also don't have as heavy a curtain as a lot of us like to use for roll-up curtains. I hate to endorse one company, unfortunately, for roll-up curtains. You can order them through like JD Barn Supply and a couple different places, JD Manufacturing online. A lot of Western Ohio and Central Ohio guys are working with Busher out in Western Ohio. Ryan Busher has a curtain line. Some of our Dairy Supply, WG and Hills both have access to a couple different companies that make curtains also. When you're going to put in a curtain, you want to measure that curtain area to know how tall it is and what length, so you get it pre-cut to order. The roll-up ones are really easy to install yourself. Those basically, you order the curtain, you have a piece of pipe you slide in, you fasten that pipe and put a roll-up curtain on the outside. I wish I should have thought of that and got some good pictures there to talk about how to build a curtain. But you put that pipe in, you fasten that curtain at the top by sandwiching it between two boards before you hang it, and then you hang it in that board sandwich, and then you build a box around each end, and then every 4 feet you want to put a strap to hold them from blowing in the wind. Had Glenn Arnold put in the chat that Holman's Equipment over in Western Ohio probably has curtains. Basically, all your major hog suppliers at least have the curtains for drop down. Roll-ups are typically a little bit heavier curtain. So you got to look a little bit harder to find those. But a lot of your dairy supply places have the ability to get those. If you're having trouble finding them, send me an email. Let me know what part of the state you're in, and I can help you locate those. If I was better at taking pictures, I could have had some great pictures from this summer. We took one of our barns and eliminated a wall and put a curtain on. Just took a nice K-saw, went down along the whole wall, and went inside and beat all the sideboards off and hung a curtain up. Just, I guess, a little bit more, and I'll work on putting that into pictures for future times when Garth's wondering about ventilation. But the drop down curtains, those, as I mentioned, are a little bit harder. So those seem easy because you mount them at the bottom, but that drop down hardware, so every 4 feet you have to mount a little pulley, and you run a cable the whole length of the curtain, and then every 4 feet you have a small rope that comes off of it on a pulley that allows that curtain to drop down and be raised with a cable winch. So getting those all lined up and all the cables perfect is a little bit more work, and they're also more maintenance than what the roll-up curtains are. But you really need a drop down at the eaves of those barns so you can manage them in the winter. Here where it warms up to 50, pretty much all my drop down curtains go all the way down. And we may start to open the roll-ups, but at least all the drops on the top of the barns get open during the day and closed up halfway at night.
Had another question in the chat. I think you alluded to this there when you were talking about some of those bank type barns. What's the best way to ventilate a shed style roof or lean-to that's been added to those buildings?
Yeah, so if you add a lean-to to that building, and you go back to my pictures there, you have a couple challenges. The one challenge is that dead-end barn. If you have that dead end where it comes up against your old hip roof barn and there's no way to get air into that hip roof, then you actually want to take and you can they make ventilators that you can put right there in that section of the barn to open up that peak point where the shed comes into the barn. If you can open that up, remove all the siding, go up to your hip roof barn and put a ridge vent on the hip roof barn. A few things to be aware of when you do that, you're definitely going to want the top hat style. You don't want to go on these old barns with native lumber and put in an open ridge. For one thing, you're probably storing something on that barn floor you don't want snow on, you don't want rain in on. Some of the new barns that use treated lumber up there, that native lumber will eventually rot and get moist, depending how it's put together. If it's just pegs and pins, that's not good for it, but opening it up and letting it vent will be better than trapping all that heat and humidity under there. A few of them, sometimes you'll see guys actually take and wrap all the rafters in those old hip roof barns if they open them up and put a ridge on them. But most of the time, if you do a top hat style ridge, you can prevent snow and rain from coming in really well and allow that to ventilate. But I run into quite a few where that's not an option to open up. So you have to look at how to put some vent caps there where they join in, where the shed meets that old barn.